let us return to our factor, to the representation of equilibrium price factors by means of this graph. I told you that the equilibrium price factor is obtained in the point, the unit point in which our two curves, constant cost curves intersect. But what happens? This is a fundamental point. When the price of one of the goods increases, for example, the price of good one increases while the price of good two remains unchanged. Well, it is obvious that the isocost curve of the first firm must move towards right. Why? Because if the levels of factor price remain unchanged, you would have a positive profit for the firm. This is impossible. This is contrary to the hypothesis of constant returns to scale. And so all the curve must move rightwards. But what is the consequence? Note that the equilibrium price factor price vector changes this way. Equilibrium price of the first factor labor increases as well, while the equilibrium price of the second factor decreases. In other terms, we obtain the following result. When the price of good one increases, since good one is more labor intensive than good two, the wage increases as well, while the price of capital decreases. Is it clear? In reality, there is a stronger result which holds in this case. Not only the nominal wage increases, but also the real one. The real one is simply given by the ratio between the nominal wage and the price of any good, for example, a good one. This is nothing but the quantity of good one that I can buy with 1 unit of labor. And the stronger theorem tells us that this inequality holds. The quantity of good one that I can buy by means of 1 unit of labor increases as well. Clearly, the same thing holds for good two, because the price of good two remains unchanged. So you have also this inequality. So this inequality. Is it clear? This is a well-known Stolper-Samuelson model. Sorry, theorem, not a model, it's simply a theorem, a consequence of Echelon model. I repeat, the theorem tells us that when the price of a more labor-intensive good increases, the wage, the price of labor, increases, not only in nominal terms, as it is clear from this graphic, but also in real terms. This is very difficult to prove, because clearly when the factor prices change, also the unit of coefficient A1, A, etc. change as well, and so the proof is a difficult one. However, we obtain this fundamental result. Now, if the available quantities of factors are not important in order to determine the equilibrium factor prices, as I told you before, it is easy to show that these available quantities uniquely determine the optimal level of production of good 1 and good 2. In order to see these, let us trace an edge box like this. And trace in this edge box the so-called expansion path of the firms. Do you remember? The expansion path is the locus of optimal combinations of factors where the level of production varies. Since there are constant returns to scale, this expansion path is linear. As you remember in the second part of the course, Salvadori surely explained this you. Well, trace also the corresponding expansion path for the second firm. For example, is this. You have the tangency, as before, in every point between isopont and isopont. Note that the slope of this expansion path, which is a converse of factor intensity, is lower than this slope. So you obtain exactly this graphic. Where is the equilibrium? Clearly, it is in this point, where our two expansion paths intersect. The first firm will employ these quantities of factors, while the second firm will employ with these quantities of factors. And the total available quantities are entirely employed. So we obtain this result. Given the quantities of factors, given the dimensions of a box, you determine the levels of production, the levels of these two isopoints, which passes by point E, large E. This is a very strange character of a model. The quantity of factors determine not the equilibrium factor prices, but the level of production. And what happens to conclude if the quantity of one of these factors change? You obtain another important result in this model. Just redraw the edge box. O1, X11, X12, X21, X22, O2. So we have our two expansion paths. And this is equilibrium. Now, let us see what happens if the quantity of one of the factors, say labor, increases. So, since labor is the first factor, you have an enlarged edge box. The basis of the edge box increases, while the height remains unchanged. So, you must continue this expansion path. You must translate the expansion path of the other good, the second good, in this way. The new equilibrium is here. What is the economic meaning of this result? When the quantity of labor increases, the level of production of the first good, the labor-intensive good, increases as well. Note, you pass through a higher isotone. While the quantity of the optimal quantity, the equilibrium quantity of the second group decreases, since the length of this segment is clearly greater than the length of this segment. So the result is the following. The quantity produced of the first good increases, while the quantity which is produced of the second good decreases. This is the well-known Rybczynski theorem. Rybczynski theorem. Rybczynski was a Polish economist. This theorem tells us that when the quantity of a factor increases, the equilibrium quantity of the good, which is more intensive than that factor, increases as well, while the quantity of the other goods decreases. But why, in economic terms, this second fact happens? It is obvious, because when labor increases and the quantity of good one increases, you need in the first sector not only more labor, which is available from the increased quantity, the increased availability of labor, but you need also of an increased quantity of capital, because the ratio between labor and capital is constant. But from where this supplementary capital is driven? From the second sector. You must reduce the quantity of capital employed in the second sector. But since also in the second sector the ratio between labor and capital remains unchanged, you must reduce also labor. And obviously, if you reduce both factors by monotonicity, the production of good too decreases. This is a well-known theorem, Rybczynski theorem. This is a correspondent theorem, a dual theorem with respect to Stolper-Samuelson theorem. This theorem can help us to understand what happens, for example, in consequence of immigration. Here in this model, there are no movement of factors, but let us suppose for a moment that in this economic system, some workers from abroad enter in the system, so that the available quantity of labor increases. The result is not, as one could expect, that the wage decreases, but simply that a greater quantity of the labor-intensive good will be produced, while the quantity of the other good will diminish. Is it clear? The effect of the entrance of new workers is not necessary to decrease the wage, but to change the proportion between the labor-intensive good and the capital-intensive good which are produced in our country. Clear? If labor increases, at some point, the optimal equilibrium quantity of good 2 will be equal to 0. Our country will be entirely specialized in good 1. But what happens if the quantity of labor increases beyond this limit? So, at this point, in order to avoid unemployment, it is finally necessary that the wage decreases. Because in this way, the labor capital ratio will increase as well. So it will be possible to employ also these other workers. Is it clear? So the intuitive theorem according to which an increase in the labor force produces a decrease in equilibrium wage holds when our country is entirely specialized in the labor-intensive good. But if the country is not specialized, if it produces both goods, the effect is not on the wage, but on the levels of production. Is it clear? This is the economic consequences of this Rybczynski theory. It's a very important theory. Well, with this result, we have concluded the introductory part of the course to read on Mascolelli and Company, chapter 15. Remember, the remaining part of the course must be studied, as I told you in a previous lesson, on my lecture notes. So I will put these notes on the Moodle platform, so everyone can study on these notes, because the paper version of the electronic version of these notes is lost. Well, there is no real problem. You will find these notes on the Moodle platform. So let us have another short interval.